Okay, hi. Let's have a look at where we are at the moment. So we have our whole system loaded up. We have a pretty large level ready to go. Here's what we had before. So I've capped all the frame rates at 60 frames per second. As you can see on the left, we have our top-down view, and here we have our 3D view. Awesome. There's just one problem here. Clearly there is a bit of overdraw. So if we look at these blocks here, we should not be able to see the back walls if we were viewing this for real. So our goal today will be to look at backface culling. How can we mathematically determine that a face should not be drawn? So we'll just switch to the paper for a second. Okay, so let's investigate how we can do this. Let's say we have a level with a bunch of wall segments and the player is looking in this direction. The first thing we need is every wall should have a normal, which is just a direction vector which indicates 90 degrees off the surface. And now I will take maybe two different examples. Okay, so let's say we're looking at this piece of wall. This piece of wall probably should be drawn because if the camera looks over to this angle, they will see the wall. So if I draw a direction vector from the wall to the camera, that's a little hard to see, isn't it? Let me just... Okay. So there we are. We draw a direction vector from the wall to the camera. That is an instance where the wall is visible. On the other hand, this wall should not be visible. It's facing away from the camera. So if I draw a direction vector from the wall to the camera, that's a case where it doesn't work. So here, if we look at the angle between the normal vector and the direction to the player, this should be less than 90 degrees. But in the bad cases, here our angle is bigger than 90 degrees. So this is what we need to test. And it turns out there is a really great way to test it. So we have something called a dot product. Okay, so the dot product between two vectors is it's denoted as so let's say we're looking at two-dimensional vectors, so they have two components. This extends to 3 dimensions, n dimensions, it doesn't matter. The formula is we take the product component-wise. So we take the product of the first two, the product of the second two, and we add those together. Okay, now this is also equal to the magnitude of the first vector times the magnitude of the second vector times the cosine of the angle between them. So this simple formula can be used to kind of indicate the cosine between two vectors. Okay. Now we don't really care about that apart from the cosine. Cosine's most important. Now if we think about our two cases, in the case where the angle between these two vectors is less than 90 degrees, well, cosine of a number less than 90 is positive. And in the case where these two vectors angle is more than 90 degrees, well, cosine of a number more than 90 is negative. Okay. And then the magnitude is always positive. So point is, I'll just redraw my diagram here. So let's say we have a wall and it has a normal vector, and then our position could be here or here. So it could be front face or back face, or I guess the player could be over here, exactly 90 degrees. So if I draw a case here, so if the result from a dot product is bigger than 0, then the wall is front facing and it should be drawn. If the dot product is exactly 0, well then we have 90-degree angle, probably don't draw it. And if the dot product is less than 0, well then this wall is not facing the player and it shouldn't be drawn. Cool, so let's look at how we actually implement that. And that's it, that's the dot product. So it's actually pretty easy to apply the dot product to do some backface culling. Here I have got this function, this is the next stage here. This will take two tuples and strip out their components and then just do the standard dot product formula. How do we use this? Well, we look at the wall object, and when the wall goes to update, normally it will just go straight and run all of its drawing functions, but we need to test that first. So we will get this direction vector. Remember, the way we find a direction vector is the end position minus the start position. So we want to start at the wall, and it doesn't matter which point on the wall we go from, any point is fine, to the position of the player. Okay, store that as a vector. And then if the dot product is bigger than 0, then the face is within that, the player is within that 90-degree field and the face is visible. So then we go ahead and run our update function, which draws it. Awesome. Okay, so let's run that and we'll see how it's going. Now you can see not everything is being drawn, only the faces which should be drawn. So if I go forwards and backwards, the walls pop in and out of view appropriately. Now if I go over where these blocks were, we can see that only the parts of the blocks which should be drawn are being drawn. And we can play around with this and yep, it seems to work. Another thing that I've done is I have drawn little arrows on the walls to indicate their normal vectors. And those normal vectors are really just calculated on the fly from the two positions that the wall's based on. Okay, so that's it for now. In future versions, we will be looking at implementing a kind of door system, right? Because at the moment we walk in here, we see everything, that's awesome, but then we see everything in all of the other rooms which may not need to be drawn. So we'll be looking at that amongst other things. And just so you can see, it doesn't make a massive difference actually, but if I uncap the frame rate for both of these, and I run the first one, I'm not going to press anything because it will just spaz out. It will not handle it very well. This is running at, hard to see, about 500, low 600s frames per second. If we go to the other version, it's now running about low to mid 600s. So this does make a difference in performance. The next few episodes are going to be about optimizing performance. After that, we will look at making a level editor. And then after that, we will port the whole thing over to C++ and it will run much faster. Cool.